I get to do the introduction of Terry Johnson here, who actually got his BS in chemical engineering, so almost chemistry, from Wayne State, and then went on to do graduate work at MIT. And here at UC Berkeley, he is an associate teaching professor. And over the years, he has won really a large number of teaching awards. It really makes me want to take one of his classes. Maybe one day I'll get to do that. But most impressive here is the Distinguished Teaching Award, Campus Award. Very difficult to get, so that was in 2013. If you read the bio that he posted, which was very cute, one thing that he's done in the past, that he's done in the past is actually co-author a book. We were just talking about it, How to Defeat Your Own Clone and Other Tips for Surviving the Biotech Revolution. So I haven't looked at that yet, but that could be interesting too. He does a lot of stuff in engineering besides teaching. He is the head undergraduate advisor. He runs all sorts of programs. He regularly attends our ChemEd group meetings and tells us once a semester about many interesting things that he is involved with. And lately he has presented to us on, I think, this topic, more or less, and it was fascinating, so I'm looking forward to a full-length version of responsible engineering. And when he's led this program, you participated in the program, and now he led it last year, and now he's going to kind of encourage somebody else to lead it in the future. But many interesting topics here. So thank you for being here.
Thank you. Please don't see that I'm a chemical engineer and interpret that I'm a good chemist, because that's not the case. I've been in the bioengineering department here at Berkeley since 2001, and this was a 3.5-day program, so it'll still be a little bit truncated, but I've tried to focus in on aspects that I think would be particularly of interest to this group. So first off, what is responsible engineering? Please don't tell anyone, it's just engineering ethics. That's it. We don't call it engineering ethics anymore, mostly because of the reaction that we get. Ethics is somebody else's business, right? Responsibility is a little bit closer to the engineering portion of things. So this is really just a reframing of an old subject, but also a broadening. Who should teach this is an active question that we consider a lot. There are sort of different solutions depending on which department you're talking about. Many times it's taught by working engineers in that field, but oftentimes it's taught by ethicists, people in the philosophy department who are teaching more sort of a rooted class in generally making ethical decisions as opposed to a focused class about making ethical engineering decisions. One thing I am constantly pushing back against is the third choice, because very often these conversations tend to end up getting refocused into what is legal and what is not legal. And I tend to move away from that, first off, because I am unqualified to tell people whether something is legal or illegal, but more importantly, because that is not necessarily the standard to which we are aiming our students to, like if they can get away with it, it's okay. The focus is more that they are making decisions about the sorts of projects that they work on, the ways that they work on them, and the manner in which they practice as engineers that are ethical. So where should this appear in a curriculum is another question. A single dedicated course is a very common solution to this, and many but not all of the engineering departments here at Berkeley use this approach. Distributed among many courses is another very common way to do this. We, in bioengineering, do a combination of these two, where the goal is to get more consideration of responsible engineering as parts of assignments in courses that are not dedicated to engineering responsibility or ethics. Also through other means. So we have an engineering week and there's a variety of activities associated with that. But these are the sorts of questions, the high-level questions, the sort of structural questions that we think about when we think about teaching responsible engineering. And I'll emphasize that I think that this is one of those things that, frankly, I believe everybody should be teaching, is discipline-specific ethical decision-making in any department. And I feel that this is one of the things that engineering brings to a campus, because we have a history of including these topics, not as well as I would hope, but a history of including these sorts of topics and that the language of responsible engineering and ethics appears in a lot of our, the Biomedical Engineering Society, the Bioengineering Honor Society, Tau Beta Pi, that there's sort of like a historical precedent to this. To bring in a career aspect, synthetic biology is something that brought bioengineers, chemical engineers, chemists, molecular and cell biologists together. And I think that a facility with the language of responsible engineering was one thing that engineers brought to the table in that case. And I think that that's, a good foundation to have. So specifically, I'm going to talk about the 2016 Warren and Marjorie Minner Summer Program. And this was based on a gift to the College of Engineering. And this program in the past has been between 3 and 5 days long. And it is a program for faculty to get together and talk about issues associated with responsible engineering. I'm already tired of me saying responsible engineering. I can only imagine where you are. Issues associated with this. And basically, the last year, I did this in 2013, the last year we chose 3 topics. One was putting case studies into context, and that was led by Gretchen Gano in the Center for Science, Technology, Medicine, and Society. I'm actually not going to talk about this one today, but that is not a knock on the quality, it's simply a focus on the sorts of things that I think that this room might be more interested in. Day 2 was led by me, inclusivity in the classroom and in engineering practice. And day 3 was preparing students to work in teams and forming fair and effective teams, which was led by Barbara Waugh at Haas. So I want to emphasize a lot of the material that I'll be showing is Barbara's or modifications of Barbara's materials. If you have any questions about what's me and what's not, please, I hope that that will be clear. So the goals. In general, to improve courses and syllabi, that's sort of like a first pass, is that people typically bring a course or courses that they are teaching that have material germane to the issues that we're going to be talking about, and that they can use examples from that and use this to improve the courses and their syllabi. It may be a course that is dedicated to ethics, or it may be a course that has nothing to do, the sort of core content has nothing to do with ethics, but because it's engineering, there's always an opportunity to frame the discussion of the physics and the chemistry and the mathematics in such a way that you are using those as tools to make more ethical design decisions. To create and empower a multi-year cohort of Minner Fellows. So these are faculty that then go back to their departments. They know other people that are thinking about similar things that they can then go to if they need a particular case study or they're having a particular issue, right? The idea is that this identifies a group who's willing to spend, approximately a week during the summer sitting down and talking with other faculty about issues such as this. And to nucleate more widespread faculty engagement. The idea is, after a couple of years of the Minner program, you have a number of faculty in that department interested in a subject. They're talking to one another, and they're able to spread their best practices that they've developed, their changes in syllabi, to other faculty in the department. It's very difficult to mandate top-down engagement with faculty. It's very difficult to say, all of you put ethics in your syllabi. Because most faculty will come back and go, well, I'm pretty sure I'm already doing that, right? And the question of best practices is something that the Minner program basically focuses on getting a group of actively engaged, very interested faculty in the departments where they can get other people excited about these issues. So I'm going to start with day 2. This is inclusivity in the classroom and in practice, and this is part of responsible engineering. So the first thing, and I'm going to go through some of these slides relatively quickly, there are active learning exercises for the faculty as part of this program. The first one is to get people talking about the various potential definitions of diversity, right? I want to surface this from the faculty as opposed to telling the faculty. And we talk about different kinds of diversity. Students break into pairs, students, faculty. And then we talk about trends. We actually show data. Sometimes this data can be surprising to many of the faculty. So there would be a group of slides for the departments that are part of the program, the averages for the College of Engineering, because it's an engineering-focused program, that include things like demographic data, gender, underrepresented minorities, LGBTQ, socioeconomic diversity, and as much data as I can find. Very often, we will try and circle back if there are if there is information that the faculty wish that they had, we can try and get that for one of the future days, right? And then I like to have pauses for reflection, which is also, active learning, but useful at pulling information together that I can then go back and the next day give back to the faculty. What do these numbers mean to you and to your department? And what's not captured or expressed in the demographic data? Departments tend to be obsessed with demographic data because it's quantifiable, right? It's numbers, like our numbers are better, right? The numbers are great. We have more underrepresented minorities, but that doesn't necessarily capture their experience in the classroom. It doesn't necessarily capture a lot of details about the climate and culture within the department. So associating information like this, it's important up front to say that demographics are important, but they're usually the first step, right? Yes?
Sorry, do you show retention information? Like,
Do
based
we?
on entering and exiting to kind of help them think about that?
Do we show retention information? I would love to show retention information. It is almost impossible to get. What we can get is steady state numbers in and out, right? But because the sort of data that we get through CalAnswers has to be de-identified, it is difficult for most users to actually pull a student came in with this code, meaning that they were in bioengineering or in material science and engineering, and then made these choices. You can see the overall numbers. We are working with campus to get better tracking of that information. And a lot of that is actually just sort of like figuring out how do we get or how do we ask for that information in such a way that it is appropriately de-identified, right? Or is only given to people for whom the identification is not an issue.
At the most basic level, you can still show the percentage that entered and the percentage of like demographic ways that graduated though, right?
So, yes, but even that gets a little complicated with the number of transfers and when they transfer. So we do have some information about that. I'm cautious about overselling it because it's a little bit difficult to interpret sometimes. Any other questions? Terminology, so I want to get everybody on the same page in terms of terminology. We talk about stereotype threat and imposter syndrome. Stereotype threat, when stress caused by perceived risk of confirming a negative stereotype can impair student performance. And imposter syndrome, which is a fear of being exposed as not really belonging. And this is a tend to downplay successes as luck and to heighten any sort of experience of failure or perceived failure. And a lot of it is perceived failure. I will have students come in and go, I've never got a 78 before in my life. So what was the average? 61. You're doing great. No, but you do understand, it was a low number. There's a lot of adjustments that happen when the students come into Berkeley, right? And I don't think that in many cases they are adequately prepared. I mean, first step is simply saying imposter syndrome is a thing. I usually in my first class say that there are two kinds of engineers. Those who say that they experience imposter syndrome and liars, right? But also to sort of prepare them for expectations in a course because they're going to be very, very different than what they would come to expect in a high school, right? Fixed ability mindsets. So a fixed ability mindset is you are born with an innate ability that cannot change versus a growth mindset in that your skills change over time. Fixed mindset, if there's a challenge, you avoid it. I'm not going to do it because if I fail, then I don't have that ability. Like I can only lose, right? If right now I perceive myself as having the ability and I fail at applying that ability, I lose the ability, right? On the growth mindset, challenges are how you improve. Effort is a sign that one lacks the ability. And I would say in engineering, in all of the places that I've been, this sense of, no, I don't work that hard. And then they work really hard, but quietly, because they don't want to see anybody seeing that they need to work really hard, is kind of endemic. Growth mindset is a path to mastery. Criticism is personal, right? Because if I say, hey, you know, I really think that it should be 2 pi, not pi over 2, right? Then you're basically, oh, you're saying I'm not smart, right? Because I'm wrong. Because wrong means I'm not smart, I don't have that ability, versus an opportunity to learn. And other people's successes are either a sign that you are less than they, right? Or they are an opportunity to go, oh, it's possible to get really good at this, right? This is a fundamental mindset, and I think that a lot of students, especially with science and math, have or come in at least with some identity of fixed mindset around those skill sets. Does that resonate? I see a couple people nodding. Yeah. Okay, implicit bias. Biases that we're not conscious of, either having or expressing. Everybody has implicit bias. We usually do the Harvard online test for implicit bias. Implicit biases are not something that we get rid of. This is, I think, important to get across to the faculty. They're something that you acknowledge and address. This is the point where I want to depart a little bit, because address is very often kind of loosey-goosey. How do you manage your implicit bias? Experience. I mean, with experience and counter-stereotypic exposure, those are proven methods, right? Education, reflection, discussion about implicit bias. All of those are true and hard and open-ended, right? I work with engineers. We like process. We want process. And process can keep you honest. Accountability. How do you make people accountable for decisions that include implicit bias? And by people, mostly me, right? Establishing and following procedures that limit the expression of implicit biases. So, we've talked about hiring in our department. You know, how do you set up fair methods for evaluating people that you're going to hire? The example that I always use is that if you asked me 10 years ago, am I calling on men and women the same in my courses? I would go, of course I am. And then I counted, and I was not, right? So now I print up a roster, and I call on people randomly, and I make sure that everybody gets called on at least once during the year. I think there's other good reasons to do that, but it started with me keeping myself honest, right? I grew up, I was born in the 70s, right? I have as much cultural baggage as anybody who grew up watching 80s television. And I want to process that, but I also want to do simple things that keep me honest, that prevent me from expressing the implicit biases that I have. And we want faculty to be thinking about those things. So, stopping with a pause for reflection, what are other definitions that we would all want to be on the same page for to continue talking about these? Okay, before I move on talking about bias at various stages of an engineering career, does anybody have any questions? Okay, so the next stage is to talk about the ways that bias can express itself. And I wanted to be very clear, it's multimodal, right? There's lots of ways that this can happen. I want people to be aware, because these are all things that they will have to do in their engineering teaching and practice, right? Emails, bias in response to emails. So instructors at about 260 institutions were given just fake email requests for mentoring. And how often would they respond if the name sounded white and male versus if the name was a woman's name or a minority's name? That is life sciences and engineering and computer sciences, right? This is the very first step. It's just responding to emails. How likely are people to respond to an email based on their perception of who is emailing them? And there's, can I post these slides if anybody wants? We'll have the citations are right here if anybody wants to look them up later. Bias in perception. So this came from a business school, basically as an MBA program, and they asked how power-hungry, self-promoting, and disingenuous was Roizen. And they gave two different sections. One section, it was Heidi Roizen. The other, it was Howard Roizen. And that's the only difference. The text was exactly the same except for the gender, and that's the difference. All a matter of perception. So then, a scenario. And this is a common scenario that I do in a student presentation. One group consistently refers to a hypothetical surgeon as he. This, if you haven't guessed, comes exactly out of one of my classrooms. It's actually happened several times. How would you respond to this in one of the courses? Usually this falls, there's sort of two camps. One would be to privately talk to the student, right? And then the other would be to, publicly talk to the student as part of their feedback, right? And one of the things that I like to surface in this discussion is the idea that you're not just providing feedback to the student who made the mistake, but to everyone else in the class who also heard the student express themselves in that manner, and that there is an opportunity not just to correct a single student's behavior, but to clarify that you knew that they did that, and that you did not think that it was acceptable or appropriate, right? I also use this in my graduate student pedagogy class. Do you take like a 301, 375 course? I think everybody has to do that, yeah. And we talk about this. We always have a very vibrant discussion of the two camps, whether you should embarrass that student or whether you should talk to them privately. Bias in recommendation letters. So these are groups that write recommendation letters. These are semantic realms following possessives. Basically, it's what gets talked about in reference letters. And this was for medical professionals. So it's fairly close to bioengineering. And you can see that training and teaching and application are subjects that are discussed more for reference letters for women versus research, skills, and career, where men tend to have that talked about more in their reference letters. Again, you're bringing this up so that if you then go on to write your reference letters, you're aware that this bias exists, and you'll at least hopefully be mindful about the way you write your letters. Bias in hiring. This one's a pretty famous one. Basically, you get, it's the hiring of a lab manager. So it's very similar to the Roizen, where you basically get the exact same resume, except one has a stereotypically male name, the other has a stereotypically female name. And how were they rated for competence, hireability, and mentoring, right? And I don't even need to do t-test on that. It's pretty clear that those are statistically significant differences. And that's from 2012. One other thing that I often note is that a lot of the fundamental research in this area is pre-2000. And especially when I'm teaching to people who were practically infants around in 2000, I prefer to not leave open the interpretation that the culture has moved on. So I try and use as many papers from 2005 and above, right? There's lots of great papers that I'm not including for that particular reason. Bias in paper review. So this was a journal that went from single-blind to double-blind review. And I want to note, double-blind review is nobody knows who the reviewer or the reviewee is, which is not true. People can guess both ways, right? So when I say double-blind, assume that this is actually very conservative, right? Like, double-blind really means that some people haven't figured out who they're reviewing or who the reviewer is. This is the pre and post review number of papers published, which is a little unclear. The better way to put it is the percent change in women and men getting papers in after the switch from double-blind, from single to double-blind. And note that if it was truly double-blind, if you had a magic wand, that you would expect the effect to be much greater, right? Yes?
Is this in terms of the graduate student who's first author or the faculty that's at the end?
First author.
Okay.
Yeah.
Because no, that makes sense. Because I would figure, I guess my assumption was that you would know, in a double-blind case, you would know who the faculty advisor most likely is because you can recognize the research tree, but you may not know who the graduate student who wrote the paper is.
That's true. Yeah, that's true.
So I'd wonder if there was still some level of bias against like female versus male faculty. I guess less so.
I don't know offhand. I would want to revisit this paper to see if they looked at that. I'm selecting one, usually one graph per paper.
Yeah.
I don't know if they looked at that or not. I just don't remember from the paper. I'll look that up.
Sorry.
No, that's fine. That's great. And then I want people to share the best practices that they have in their own departments, right? I think coming back to this, it can be a good way to get faculty talking about what they're doing right, but oftentimes that also leads to, and I wish we did this, and I wish we did this, right? It's kind of building momentum to considering these issues in their classrooms. Bias in advising. This is more recent. This is kind of a more recent discovery, and I'm working with the Biology Scholars Program on their advising group. I'm really interested in improving advising. I'm sure none of you have noticed that faculty have zero training in advising, right? We all do a great job. That is a lie. And I mean, we don't really know how to advise, and student advising can be very simple or very complicated. And oftentimes you do not know which situation that is when a student walks in the door. Now there's a variety of issues. I'm not going to show the data behind this, but the first one would be that instructors with fixed ability mindsets, so the ability is inherent, not something that can be grown through effort, tend to comfort students, not strategize for improvement, right? Like you can have, oh, okay, you're having problems in this class, this is what we're going to do. If you don't do well in this class, that's great. You can still be a bioengineer. This is just the path that you want to take, right? Like going forward, we've got different options, right? We're gonna, this is what I want you to do now. I want you to come back to me later. If you're locked into a C in this class, it is not the end of your career. We'll just sort this out. The comfort is typically like, yeah, some people are bad at this. Which is not particularly helpful, but that does happen. This is the student perception. So the black bar is a comfort feedback. The hard to see sort of cream bar is the control, and the gray bar is a strategy feedback. This is how fixed does the instructor think my math ability is. So the comfort feedback is a clear signal to the student that you think that I either have it or I don't, right? How invested am I in success in this class drops significantly with the comfort feedback, and my motivations drop significantly with the comfort feedback. So there are types of feedback that are helpful, and there are also types of feedback that are tied to particular mindsets about student ability. I want to say one other quick thing about fixed ability mindset and implicit bias. So let's say that you looked at the emphasis on brilliance in a discipline. What you do is you basically go to a bunch of academic disciplines and you say, how brilliant do you have to be to succeed in this discipline, right? And then you plot the percentage of women in the discipline. I'll pause for a second. All of this, you look at all of the original data, there's actually no difference between women and men. No difference between their skills and abilities according to all of the metrics that you can get from their applications. This is not a measure of whether the women are actually brilliant or not. This is a measure of, hey, do people need an unidentifiable thing to succeed in your discipline? If yes, my implicit biases rule, right? Because effectively, I don't think about it. I just say, oh, they need that extra special something, right? That's something that I can't define, which is my implicit bias. When you just say, oh, you need this special thing that I can't define, you are saying, I'm not going to put a structure on my hiring processes that controls my implicit bias. I'm going to give my implicit bias free range. You see the exact same thing with African American applicants. And again, there's no difference in the quality of these applicants by all measures. This is based entirely on how the hiring practices are affected by requiring an unidentifiable something. Does that make sense? And I think that this is a real clear measure of why you need process, right? The more you sort of trust your gut in many cases, the more you're simply saying your gut is a jerk, right? Your gut has some useful things to say occasionally, but it's not necessarily good at hiring engineering professors. So before I move on to classroom climate, are there any questions? Yep.
I guess, what kind of reactions do you typically get from the professors who are participating in these programs, and how do you manage or navigate that?
So I would say that the professors who participate in the minor program are self-selected professors. They're interested in these subjects. Usually they're either, oh, I knew this, or I'd heard something like this, or oh, I'm glad to know that because that will be useful in talking with other faculty. So I have like programs like this that are not mandatory, right? You're self-selecting for people that want this. And I think that that is a valid way of getting this material out there. When I have shared this, you get all kinds of reactions, right? One in engineering that happens a lot is like, I wouldn't statistically analyze that the way that they did. And I'm like, yeah, there's 100 other papers that have seen the same thing. Like this isn't necessarily the most useful discussion for the limited amount of time that we have to talk about this very particular issue. But I would say that the level of outright resistance is usually pretty low. Occasionally, I would say that the most of the resistance that I perceive are people that are afraid to talk about these subjects, right? Like they're just super uncomfortable about discussing them at all. They feel unprepared to discuss them, and I understand because I've been there, right? That's kind of why we need to nucleate and have people that are comfortable or more comfortable so they can kind of guide faculty in their departments for navigating these situations. Yeah.
What is the usual demographic of faculty in the room, and is that ever discussed in your?
Oh, the demographics of the faculty shows up all the time. In fact, the data that I would have shown earlier would have included campus demographics for faculty as well. Yeah, no, and it's important. I mean, clearly that affects the types of mentorship that people have. It affects imposter syndrome, like the climate in the department. And that often leads to positive change in hiring, right? Like, people then start asking the question, which some people are always asking, but more people ask the question, so what percentage of the applicants to this pool were women, right? What percentage were, and again, demographics is not the end of the story, but getting people to even think about that for the pool of applicants that they're looking for is a useful start, right? Stereotype threat. That is from Claude Steele. Basically, the stereotype threat condition versus no stereotype threat. That is mean items solved on math SAT, right? The stereotype threat condition is sort of this is a test of inherent ability, right? Inherent math ability. Versus the no stereotype threat, which is another statement. The exam is exactly the same, right? It's just, are you priming the students to think about this as a test that could confirm a negative stereotype or not? And you see the same thing with men and women. And these are just two pieces of information. The teaching intervention, by the way, which is a good segue in this case, is to simply say there's a thing called stereotype threat, right? And to prepare the students for considering that when they're taking the exam, right? So then, scenario, a student makes an appointment with you to speak privately, admits to feeling overwhelmed this semester, is not sure whether they belong in engineering. How do you respond? This is a half-hour discussion, easy, right? Every faculty member has dealt with this that I know multiple times. It involves a great deal of diagnosis, right? The first step is honestly finding out, do you really not want to be an engineer anymore? Are you not happy doing it? Or have you been convinced that you are not capable of doing it? And figuring out where the student is can be very difficult, because very oftentimes a student who feels like, I can't be an engineer, will not say that. They'll say, I don't think I want to be an engineer anymore, right? So getting a diagnosis and sort of figuring out where the student is, and supporting them in such a way that they feel the freedom to make either decision, right? Like, if you decide that this is not for you, we will support you in doing that, but letting them know that you shouldn't let a single Math 53 exam make this decision for you, right? And a lot of this is actually just sharing failure. Luckily, I have a wide variety of stories in that particular area. But I want to focus a little bit on interventions. So, as I had said before, this is a complicated subject. Like, implicit bias is very complicated. You spend your lifetime trying to sort that out, right? But where are places to start? So what are interventions that faculty can bring to their classrooms relatively easily that are shown to have an effect? This is my gateway drug to get people doing stuff in their classrooms that they can then expand upon. So self-integrity exercise versus stereotype. Students identify their most important values from a list of values. It's one sheet, like 12 different values. Then they do a brief written exploration of their choices. Why is that value important to you? Total time about 15 minutes, and that is the effect over an entire class block. The closed diamonds are European Americans in either group. The open squares are African Americans in the control group. They actually choose the least important values. The closed triangles are African Americans in the affirmation group. And this is based on psychology that says, you know, a reminder of one's personal values can have sort of like a vaccinating effect against these stereotypes. You see the same thing with men and women. This is a later study in 2010 with a values affirmation. The idea being, if there is a potential stereotype threat, reminding students of their values. And it doesn't have to be like this. I do something similar in my classes, but just tying the material to people's values, making them think about their values, right? Belonging versus imposter syndrome. So students are given a narrative framing social adversity in school as shared and short-lived, and the students then write and film personal experiences in line with that narrative. I do not have them film them. Basically what I asked the Biomedical Engineering Society to make a brief video, get a bunch of people together, and just talk to the camera and say, oh, my sophomore year sucked. And to say why, and what they did to change things, and how it got better, right? And then I asked the students in my first year class to write a brief homework assignment. It is all of 2 of 20 points, right? Talking about a similar experience that they've had and what they've done to overcome it. And the reason for that is this is, by the way, one exercise, a social belonging treatment at the end of the fall term has an effect on grades throughout 4 years. And this is one experiment. And if, you know, the statistics just happen to shake out that this is a particularly broad effect, I'd be happy with half that, right? And again, it's very brief. You're basically just reminding students that, yeah, college sucks sometimes. It's not just you, right? And there are people that have experienced this before and moved past it, and they can tell you how they moved past it. I firmly believe that if you are a first year experiencing failure, perhaps for the first time, and you see a junior going off to a research experience for undergraduate thing somewhere, well, that person's never made a mistake in their life. And the faculty, oh, yeah, I've read their CVs. Everything has worked the first time that they did it. It's been a perfect golden, you know, like trail of rose petals, right? But that's actually how we talk about our academic careers. It's lies. Reminding students that that is not the case. Goal setting. So this was a class in Olin College where students would make a toy, basically, but it would be a toy that you would laser cut out of a material, so it would store energy and then release it. So it could be like a, you ever see those jumping frogs? You kind of bend it, you put it down, you wait a while, and it goes poing, right? But it would be based on that principle. And afterwards, the first time they ran this class, they asked, what did the people do? So the first year, women reported doing more of needs finding and preparing presentations. Men, practically all of the CAD, especially the modeling in CAD and the building of prototypes, very significant differences in the amount of time that people spent. Again, this is a very simple intervention. Number one, you show people this data. The second year, they said, here, take a look at this data. This is a trap. This is a cultural trap that you can fall into. And before you work in a group, I want you to write briefly, what do you want to get out of this group? What do you want to get out of the project? How do you want to develop professionally? Set goals for yourself so that they aren't set for you. And that was the next year. So the emphasis on intervention is what are relatively simple things that can be done quickly, can be added to your syllabus. And this is not the end. The goal is that faculty will then build upon these. And then I get people together into pairs. I'm not going to go over each of these, but to talk about personal experience that's relevant to the topics that we've talked about, how they dealt with it at the time, and how they would deal with it, given the advice of the other faculty and the sorts of things that we've talked about. And then we discuss those strengths. Okay. I know it's a lightning thing because I have this class at 5 and I apologize. But this one is shorter than the first part. This is Barbara Waugh at Haas. I want to emphasize these materials are based on hers, not mine. Some of them I have built, but they've been based on her work at Haas and previously at HP about building fair and effective teams. So in engineering, what we have historically done is thrown people together in groups and said group work is very important, and then just backed off and hoped that nobody lit on fire, right? Like just to not give any of the students any training in how to work effectively in groups. And I would say that very few come to Berkeley as first years having had that training, right? Very often they have the anti-training. They were in groups in high school, and so what's an effective group work? An effective group work is where I hide the work from the rest of the group, and I do it all so they don't mess it up. Which, when you have 4 people together in a group, all of whom want to do that, it's hilarious, but not effective. So, how do you get groups together? There's a variety of options. You can self-select groups, which I did for a long time and I'm moving away from. You can have random groups. What I typically do is something like a semi-random group. There's a software called CatMe, catme.org, funded by NSF, that can help this. Basically, the students take a quiz, and it helps to sort them semi-randomly, but tries to match students based on interest, or their schedule, or potential demographics. Pechakucha is a little more specific, where you have the students individually propose projects with 3 slides. They share their proposals. They have students vote for several favorites in an online survey. And then you create teams based on preference, favoring diverse teams when possible. That, I think, is particularly good for a senior level course that's got maybe 30 to 50 students in it. For larger courses, I usually go semi-random. I have an asterisk on diverse teams because there are questions about how you want or should do this. There's evidence that teams that have only a single woman in them, that their experience in the team tends to be worse than if the team had at least 2 women in it. But there are Title IX issues associated with that, so I bring that up, and that's why I have the asterisks on there. I don't necessarily know exactly where I fall on that. I think that that's a complicated subject, but it is an option for teaming. Like, that is a way that you can potentially do teaming. I generally do random, focused on schedule. Like, I actually think that schedule tends to be the most important, in part because students are forced to say, when are you free? And then later on, if they go, oh, I can't make it at all, You said up front you were free. Terry posted it on the webpage. This is the time. Then there's an individual profile. This is how I do it. This is an exercise that they do in their discussion sections. I ask them to take like 15 to 20 minutes to create a single slide of images that invite questions about aspects of your own life that you're willing to share with others. Pull images from online or draw them. Avoid words where possible, which I'm terrible at. Considering the following when constructing your profile. Lots of questions. This is very open-ended. And what the students then do is that if you were my group, I'll leave that, that's Barb's version. You would see my individual profile. Everybody in the group has a chance to ask a question about one of the images on the profile. And I know we're limited on time, but let's say, for example, someone asked me about this. And so, well, that's a Babylonian math problem, right? It's a word problem, and if you translate it, it looks very much like the kinds of word problems that you would get in 5th grade. It's just involving hectares and crops on your land. And if you ask me a question about this, I would talk about Aristotle and Plato and Greek philosophy. And why do we do this? Partially it's just an icebreaker, but the main purpose of this exercise is to surface diversity, right? So if later on there's something of historical interest, right? Like we're developing a text analysis tool that could be used on historical data. Wasn't Terry interested in Greek philosophy? You probably like some historical stuff. This comes from work at HP that determined that diverse groups work better than non-diverse groups. They're more effective, but only when people are willing to talk about the diverse life experiences and skill sets that people have. This is a way to get people talking about, the example that Barb uses is a team where they were considering a business plan that would basically have a product in another country, right? And the team worked on this for weeks. No one on the team knew that one of the people on the team had lived in that country for like 5 years. None of them knew. And that person had not brought it up. There was no context to do so. They may have felt that it was arrogant to say, well, I don't think that would sell in this country because I've lived there, right? But this is a way to get people talking about, oh, I bring this to the table, right? And that way the team can actually call upon the diverse skill sets and life experiences that are contained within. Building a collaborative plan. This is a way to get everybody on board with a particular plan. And like I said, I don't expect you to read all that. But we will post the slides. You'll see what are our goals, what are our roles, what are our procedures, and what are our relationships, right? And to set ground rules for how the team will function. So if the team brushes with dysfunction, which, having been to many faculty meetings, is I'm familiar with, it is nice to be able to refer to an agreement beforehand. Like, no, remember we said if we would have a disagreement, we deal with it this way, right? And finally, a pulse survey. And this is something that happens about halfway through. There's a follow-up survey that I can send along for after a team has finished. But this is, how are you doing? So the first one is sort of like to clear the palate. For each of your teammates, write one line that describes their contribution to the team and include your own contribution as well. And it's a good thing, right? Everybody is going to see what other people said they did well, right? That's question one. So they would go, Terry did this well, did this well, did this well, did this well. Oh, okay, so people said that I was good at time management, right? I got some positive feedback. Question two, please distribute 100 points among your team members, including yourself, for their overall contribution to the team's efforts. The total points must add up to 100. Report back to the me, right, is the average, not the individual, but the average of what everybody else thought that I had done, right? So if I went, I'm pretty amazing. I did about half the work in this 5-person team, 50, I get 50 points. And then the average is 12, I'm like, oh, this is a nice, quiet signal, right, that the rest of my team significantly disagrees with how much I'm bringing to the table, right? And it is a way to give that feedback. It's quantitative. It is semi-anonymous. I see it and the team see it. So it's a way to start discussions in a way that's fairly non-controversial. It's always a little bit of controversy, but better this than to go through the entire project thinking, you know, like I'm the star, and they're wondering, where is he? We would like to follow up with the program with an all-Minter Fellow gathering in January, February 2017. We haven't done this before, but we now have many, many years of Minter Fellows. We want to get them together for coffee, potentially talk about next steps, what we can do now that we have a cohort. I think there's about 30 faculty in the College of Engineering who've been through one iteration or another of this program. And thank you. If you have any questions, I'm almost on time. Yeah.
For your fellows that go through the program, what are your hopes for how the faculty participating in this will actually create change in their departments or their groups? Like, are you having them disseminate the information to other faculty, or?
So we urge them to disseminate the information to other faculty. We don't write their cases. So it is an exercise of soft power. What we want is for people to come out of the program with syllabi and practices that other faculty in their departments will envy, right? Like, oh, that sounds like a really good thing to do. Oh, that sounds really effective. And that when they're sort of turning materials over to someone who's teaching a new class or they're co-teaching courses, that will be the method of spread, right? And I would say that has been somewhat successful at a guess, right? It's very hard to quantify these things, but I know that in the time that I was in the Minter program and now, it's clear that many more people are aware of the program and what it does. And there's more people teaching with materials that they have considered through the program. But I think, you know, it would be nice, for example, to introduce, I'm gonna make up a number, 5 mechanical engineers, all have been through the program. In different years, they might not know one another, and then they can all sit down over coffee and go, you know, wouldn't it be great to create a module? Wouldn't it be great to do this? And that is the goal over the long term, is to nucleate a small group of engaged faculty in every department who can consider the appropriate practices for their department.
So I might have missed this from the beginning, but do you have a short, like a make and take session at the end where they can come up with ideas to take with them on the spot? And
Yeah, so there's a half day at the end. It was actually a 3.5-day program, and the last day is a consideration of next steps. We bring out the syllabi that they applied with. We tape them to the walls. We have everybody write questions, and people take that back, and then they do as they will, right? You know, like they take the changes that other people suggested, that they liked, and they apply them. That's actually where the plan for coffee in January or February came out. People said they really wanted to meet the other Minter Fellows from previous years.
Do you ever do the kind of the pulse or the slide with faculty? Do the faculty, like, you know, it strikes me it could be good for faculty meetings and
The individual profile?
places. Yeah, yeah.
We did it live. We demoed it in the Minter program. People loved it.
So
Like,
everyone did, all the faculty there did their own.
Yep. We all brought those. An anecdote. So I now do I assign students to groups, right? And I do it taking into account their schedules. And the first year I did it, there was a very small vocal minority. This was the worst thing that had ever happened, right? I really wanted to work with them. And then there were a large number of people who kind of quietly said, either to me or on the applications or on the evaluations, that I'm really glad you did that, right? So I think that there's a small group who's confident of like just grabbing a group and they're like on it, right? Like, oh, we're working together, right? And then a larger group that are not well served by just sort of like go find a group, right? This year, I added, I'm still doing that, and I assigned groups, but I added the individual profile exercise so that people, right when they got together and got assigned to their groups, their next discussion was that. No complaints this year. So I think that a lot of it has to do with the discomfort of meeting and talking with other people. I'm actually going to ask that question in the evaluations. I want to hear more about that later.
And do you check up on faculty and what they have actually done later? I guess you'll do that at this group. I mean, not in a punitive way, but just curious how much they manage to do, how many people do the very specific things you suggested.
So we don't check up, but we do end up a lot of times doing guest lectures for one another. That's very common. And that is a way to see like what someone's syllabus is. I actually gave a guest lecture for a group of architecture students. I'm in bioengineering, it was hilarious. But it was interesting, and it was an opportunity to sort of see in leading that discussion, I was able to talk to those students and say, so, you talked about something like this, and they would say, oh, this is the conflict of interest cases that we have talked about. And that, I think, kind of doing lectures for one another is a really good way to figure out what they've brought into their classes, because it comes up in the discussions.
It looks like he's heading out.
I have to run to the other side of campus. It was a pleasure. Wish me luck on getting out of this building. And enjoy the cookies. Thank you for inviting me.
Thank you.